Hello, everybody. Dr. White back again, this time with working some of the odd-numbered exercises from section 1.1. So, um, first exercise, I'll go ahead and read from the book. Let's see here. Here we go. Of a group of patients having injuries, 28% visit both a physical therapist and a chiropractor, while 8% visit neither. Say that the probability of visiting a physical therapist exceeds the probability of visiting a chiropractor by 16%. What is the probability of a randomly selected person from this group visiting a physical therapist? Okay, so they got a probability question. Let's set up what's our random experiment. Our random experiment is picking one of these patients at random. Everybody has an equal shot at getting picked. That's how I'm taking the word at random. Okay, and let's set up a couple of events. Let's let T be the event that the patient visits a physical therapist. Let's let C be the event that the patient that we randomly picked visits a chiropractor, okay? Well, the problem told us that 28% of the patients both see a physical therapist and a chiropractor, so they're telling us that the probability of T intersects C is 0.28. They also say 8% visit neither. So the probability of not visiting a physical therapist and not visiting a chiropractor is 0.08. And they tell us the probability of seeing a physical therapist exceeds by 16% the probability of seeing a chiropractor. So P of T is P of C plus 0.16. Okay. So again, kind of think of your Venn diagram, so useful in these situations, right? Outside of those two circles, kind of like here where I've got my mouse and here where I'm pointing, with this arrow, outside of those circles is the T prime intersect the C prime. And it is totally disjoint from the T union C, which is those two circles put together. And together they make up the whole sample space. So we can see that that union, the T prime intersects C prime union with the T union C, is the sample space. That little set theory fact is what gets us going, that union is S and that it's a disjoint union. Those are two mutually exclusive events. So using those facts plus the third part of the definition of probability, we get that the probability of T prime intersects C prime plus the probability of T union C is the probability of S. And then using that the probability of S is 1, which is part of the definition of probability, and using the given information about the probability of T prime intersects C prime, we get this equation right here, from which we can algebraically compute that the probability of T union C is 1. Now, we need the probability of T, remember. That we need the probability the randomly selected person visits physical therapist. We've only got T union C so far. Whoa, it's not 1. There's a total mistake here. Like here I have already wrote it up. I'm making a screencast. This answer's wrong written, so I'm going to correct it right here. I can't write. I got to talk it. This is a 0.92, folks, not a 1. What am I, nuts? So 0.92 is the probability of T union C, okay? But by that theorem 5, that's the probability of T plus probability of C minus the probability of T and C. And so it's the probability of T, which is the probability of C plus 0.16, we were told, plus the probability of C minus the probability of T intersects C, which is 0.28. And so this stuff works out to 2 probabilities of C plus a 0.16 minus a 0.28, which is a minus 0.12. And so 2 times the probability of C minus 0.12 is equal to, sorry, that's a 0.92 right there. Now add on the 0.92, add on a 0.12, and we get a 1.06. And then divide by 2 to solve for the P of C, and we get that P of C is 0.53, not 0.56. Okay, it's 0.53. That's P of C is 0.53. Add 16% to that, and we get to 69%. So P of T is 69%, not 72%. So sorry. Yuck, yuck. Hate teaching online. You dig yourself in with these screencasts. Oh well. So exercise 7. Let's give this one a try. So let's read it out. Given that probability of A union B is 0.76 and the probability of A union B prime is 0.87, find the probability of A. And so they're giving us these two facts, this one here and this one here, and saying off of that we got to get the probability of A. I'm a little skeptical. I don't think we can do this, but let's give it a try. We'll draw a little Venn diagram here, and so we got our A circle, we got our B circle, and we got the S sample space. And the X is everything that's where I got my mouse going, you know, the little crosshairs here. So that's just this stuff that's in A, but not anything else. The Y is the intersection of A and B, and the Z is the stuff that's in B, but not in the intersection. And the W is the stuff that's not in A and not in B, okay? So we can see that those 4 things, X, Y, and Z, and W, have to add up to 1 because that's probability of S. And we also know that the union was 0.76, so the X plus Y plus Z has to be 0.76. And they also tell you that A union B prime is 0.87. Well, A union B prime would be, that would be the, oh, it's the X plus Y plus W. Yes, there is a way to get this. And so here I am like saying that there's no way to determine because I've got this written wrong. This third thing here should be written as X plus Y plus W, right? Everything that's in A or not in B would be X plus Y plus W. Okay, that would be enough to figure stuff out because then, let me see, I could subtract. I could take like this equation here and subtract off this X plus Y plus W is 0.87. Or let me do it the other way. Let me do X plus Y plus W, take away X plus Y plus Z is 0.76, and you would get a W minus Z would be a 0.11. W minus Z would be 0.11. Yeah, I'm still not sure I could do it, but heck, I think this problem is now probably solvable. And I'm sorry, I can't just like talk it through. I don't have like one of those tablets right here to write it up. Shoot. Okay. Let me try number 11. See if I have any better luck. A typical roulette wheel used in a casino has 38 slots that are numbered 1, 2, 3, all the way up to 36, and then 0 and 0, 0 respectively. The 0 and the 0, 0 slots are colored green, okay? Half the remaining slots are red and half are black. Also, half the integers between 1 and 36 inclusive are odd, right? 1, 3, 5, 7, all the way up to 35. There's 18 of those. They're odd. The other half, 2, 4, 6, all the way up to 36, are even. And the 0 and the 0, 0, it says, they don't count as either odd or even. A ball is rolled around the wheel and it ends up in one of the slots. We're going to assume that each slot has equal probability of 1 over 38 of being landed in. And we are interested in the number of the slot into which the ball falls. Okay, define the sample space S, they say. That's part A. Well, S would just be this set right here. 1, 2, 3 up to 36, comma 0, comma 0, 0 in brackets. Part B, let A be this event here, getting the 0 or the 0, 0 slot. What's the value of the probability of A? Well, it's 2 things out of 38. 2 over 38 equal likelihood principle. Okay, part C says let B be the event of getting a 14, 15, 17, or 18. What's the probability of B, it asks? Well, that would have to be the number of items in B divided by the 38. Again, equal likelihood principle. Part D, let D be the set of all outcomes that correspond to odd numbers. And so, well, D is this set of numbers, and that's 18 numbers. And so the probability is 18 over 38. Well, that was easy. Okay, how about number 13? Divide a line segment into 2 parts, it says, by selecting a point at random. Okay, so you got like a stick, okay? And you just like randomly break the stick at a spot. And you're like equally likely to choose any spot between the ends of the stick to break it at, okay? And then you get 2 pieces. And use your intuition to assign a probability to the event that the longer segment, the longer new stick, is at least 2 times as long as the shorter segment, the shorter stick. To kind of set this up, you're supposed to use your intuition. I need to intuitively figure out like what are some probabilities for events in this kind of situation. So my event is I'm randomly picking a point on this line segment, which I'll think of as going from like 0 to L, 0 to maybe L for the length of the segment on the real number line. And I'm like randomly picking a point between 0 and L. And like the events would be like the subsets of that set of points, you know? And I'm interested in like finding the probability for a subset that's just an interval of numbers. What would be the probability of picking a point between A and B? Okay. Well, if all the points are like equally likely to be picked, it seems to me that it should be the length of this interval divided by the length of the entire interval, right? The chance of landing in this interval should be this length divided by this length. That's my intuition at work. So here's my intuition as a formula. Now, it really doesn't matter how long the interval is. I'm just going to assume the interval is 1. You know, it could be 1 foot, it could be 1 inch, it could be 1 mile, it could be 1 Homer unit. I'm just going to assume it's 1. And so then it makes it simpler. The probability would just be B minus A, the bigger number minus the lower endpoint on the interval. Okay? So let's think about this. Again, we got our interval that we're going to randomly break up. And so it starts at 0 and it ends at the 1. And what I'm going to do is I want to mark in every breakpoint where the longer resulting stick would be at least twice as long as the shorter stick. So what if your breakpoint landed between 0 and a third? It's like, say you landed here, here, all right, where I'm waving my mouse. Well, then the longer stick is like all the way up to here, and the shorter stick is very short. It's definitely twice as long. All the way up to a third. At a third, the longer stick is 2/3 in length, and the shorter stick is 1/3, exactly twice as long. You go anywhere between 1/3 and 2/3, you break anywhere in there, and the longer will not be twice as long as the shorter. But if you break anywhere between 2/3 and 1, then the longer will be the left hand, and it will be at least as big as the short, at least twice as big as the shorter on the right hand. So the event that the longer is at least twice the shorter, this event that I'm calling M here, that event is this disjoint union of intervals of points. 0 to 1/3 union, 2/3 to 1. And once you found that out, it's really easy to find its probability. Those are disjoint events, so the probability of M is the sum of the probability of landing between 0 and 1/3 plus the probability of landing between 2/3 and 1. And the first probability is 1/3 minus 0, which is 1/3. And the second probability is 1 minus 2/3, which is 1/3. And so the probability of M is 2/3. Ta-da! So you've got a similar problem to do for homework. So sorry for all the cock-ups for the first couple of problems, but that's the way screencasts go when you got to move fast. Bye-bye.